Hi everybody. Today we're going to be solving one-step equations. And really, you know we're in Unit 0 right now, so really this is a review more than anything. I want you to pay attention very closely to the process that you're going to be taking today. Let's start with the I can statement. The I can statement today is, of course, I can solve a one-step equation. That means that with just one step, you're going to know the value of your variable. A couple of side notes is, first of all, to isolate the variable, and that means to get the variable by itself. The wonderful thing about you working through these videos this year is going to be that you're going to be able to stop the video when you need to go get a drink or go to the bathroom or your brother's bothering you. You can pause it, which is what you could have done just now if you felt like you needed a little bit more time to write in get the variable alone or get the variable by itself. So please keep that in mind as you're going through the videos this year. The second note is to use inverse or opposite operations to solve. So what that means is in the original problem, if the problem calls to add, you're going to use subtraction to solve. And if the problem is subtraction, you're going to use the opposite or inverse operation, which is addition. And then you know the opposite of multiplication is division. And then division, of course, is multiplication. To solve an equation, we're going to isolate the n in the first example or get it by itself. Notice it also says to check your answer. As far as checking your answer, I would say check the first few problems on any type of homework assignment. Like, for example, you're going to have a cryptic quiz and you're also going to have a one-step equation page. Check the first few, and then if there's a problem that you're just not really sure if you did it right, then I would suggest checking it. Or if nothing else, just kind of going through the problem when you're done and saying, does my answer make sense? Is that true once you get down to the bottom? Even if you don't write it out, at least you kind of do that mental work. So number 1 says 7 is equal to n plus 3. In other words, what number do I add 3 to get 7. That's ultimately what we're trying to find. So to do that, we're going to think back to our first slide, which says use the side note of isolate the n. So we have to think about what else is on the same side of the equation as the n. And we can see right away that that's a positive or add 3. So in my mind, I'm saying, okay, if I'm adding, the opposite of addition is to subtract. So to solve or get n by itself, we're going to subtract a 3, not only on the right side of the equation, but on the left side as well. And I want to make sure that you're writing that down on your paper. We're very neat and organized in math. So on the right, we end up with 4. Please make sure you line up your equal sign. I don't want you to write the line going through, but just note that they are lined up, and then n is all that's left on the right. The 3's, of course, cancel. Mission accomplished. That's what we were going for. We wanted 3 minus 3 to be 0 because the only way to get n by itself is to have a plus 0 on the same side of the equation. So you're going to know right away if you get to that step and you say 3 plus 3, let's say you forgot and you added 3 instead of subtracting, you would have ended up with 6. And that's not the direction we're trying to go in. We want that just to be a 0 on the same side of the equation as the n. And then in my opinion, I'm not going to count it wrong in your paper if you don't do this, but that just feels a little incomplete to me. Since I'm solving for n, I want my final answer to say n is equal to 4. And just like I've done, I would like for you to put a circle or a box or a cloud or something around your final answer. And then as far as the checking, what that means is 7 is equal to 4 plus 3. And we know that that does, of course, check. Moving on to number 2. In this case, we're also solving for the variable n. So we want to think, isolate the n or get it by itself. To do that, I have to first ask myself, what else is on the same side of the equation as the n? Well, that's going to be a negative 6. The opposite of subtraction or negative is adding 6, and we want to do that on both sides of the equation. Then as far as checking purposes are concerned, I also want to remind you to make sure equal signs are lined up. Then we would have negative 3 minus 6 is equal to negative 9. Just a couple of thought processes there. First of all, you are combining like terms. You're combining a negative 3 and a negative 6. So, of course, if you're in the negative and you're just continuing to go in the negative, of course, you're going to stay in the negative. You could also think of it as I gave my friend $3 and I gave my sister $6. Now I'm $9 in the hole. Or the temperature is 3 degrees below zero and it just dropped an additional 6 degrees. So then we would be burr cold at negative 9. Number 3, 5x is equal to negative 55. You'll notice that on number 1 and 2 we were adding or subtracting. Now we're going to move into some multiplication and division. So the process is going to be a little different in terms of using now, instead of multiplication, instead of adding and subtracting, the opposite of multiplication is going to be division. A couple of terms that we need to talk about before we start multiplying and dividing is the word you're going to hear me say 972,000 times this year, and that is coefficient. Coefficient is so important because it's always the number that you multiply or divide by. Really, you're always dividing by it, but the process you're going to take is a little different if you're dealing with an integer as opposed to a fraction. In this case, we have an integer, so it's really simple. We're just going to divide by 5, or the coefficient, on both sides of the equation. We know that a negative divided by a positive is a negative. So anytime we have two different signs, then we have a negative answer. If we have the same signs, then the answer is going to be positive. Ultimately, what we're answering here is 5 times negative 11 is negative 55, and we know that that does check. That happens at least once a session where I pull out the microphone. Sorry about that. Moving on to number 4. 49 is equal to negative 7b. So we want to know, what are we multiplying by negative 7 to get a positive 49? We always divide through by the coefficient. In this case, the coefficient, which is the number in front of the variable, is a negative 7. So we have a 49 divided by negative 7. We're going to do that on both sides of the equation. So it looks like we end up with b is equal to negative 7. So in other words, negative 7 times negative 7 is positive 49. To check, And that works because a negative times a negative is a positive 49. And the last slide, I want you to just kind of listen for a minute. I've got a couple of notes, and maybe you can write those towards the bottom of your page. I just want you, because as you go throughout problems this year, you're going to see them look a little different. So you might see 1/4C. But I want you to understand that that's exactly the same thing as C over 4. So in other words, what do I mean? What do I mean by that? How are those two the same? Well, if I have 1/4 times C, I could just put that over 1 if I need a numerator and a denominator. You never change the value of a variable or a number if you put it over the number 1. And so we want to just look at the numerator, so we're going to multiply the numerators, multiply the denominators, so you can clearly see that 1/4C is exactly the same thing as C over 4. And you may see that throughout the year. You're going to see it written differently. Look at our number 1 versus number 2. That you can see that those are written differently. So let's take a look at number 1. The problem is 20 is equal to 1/4 C. So here's where the idea of multiplication and division goes. This is multiplication. Ultimately, you've got 20 is equal to 1/4 times some number. That's ultimately what you're trying to find out. So if we go with that rule of you always divide by the coefficient, because the opposite of multiplication is division, then here's what we're looking at. And just bear with me for a minute. You can take these notes, but we're not yet ready to solve number 1. If I were to divide by the coefficient of 1/4, that's what it would look like, but that is a big no. And I know some of you are looking at that going, that looks really crazy, Miss McDaniel. I've never done anything like that before. And you're exactly right. And here's the reason why. If I'm doing pencil and paper math, 20 divided by 1/4. I know you guys all know this, but I just want to remind you, you're going to leave the first fraction alone. In this case, it's just a whole number, but it doesn't matter if it's a fraction or an integer. Change the division to multiplication, and then change the second fraction to the big number here, or big word, reciprocal. And I definitely want you to write reciprocal down on your paper. So ultimately, my answer would be 80, and that's exactly what we're going to get on this problem, but I just wanted to show you kind of an older idea when you were doing that pencil and paper math, operations with fractions, and how that worked, and why this works and what we're doing. And that's why we say, really, if we're dealing with a fraction, the opposite of, or a fraction is a division problem, so the opposite of division is multiplication. So that's why when you see a fraction, you're thinking, that's a division problem. What do I do to undo division? I multiply. You're not just multiplying, though. You don't just multiply by that number. You multiply by the reciprocal. And this little second idea here, this little side idea, that's the reason why. So let's look at the first example. My eraser is not working. Okay, so what do? We don't want to write 1/4 divided by 1/4 because we know that looks sort of ridiculous. So instead, we're going to multiply by the reciprocal of 1/4, which is, of course, is 4 over 1. I prefer just to write 4. The reason that works is because 1/4 times 4 is 1 whole, and so all that's left on the right is a C. So you've heard me say this before. Line up your equal signs and then flip this around so your C is on the left and your final answer of 80 then is on the right. As far as checking is concerned, you're saying 20 is equal to 1/4 of what number? 1/4 of 80, or 80 divided by 4, then is 20. Moving on to number 2. A over 5 is exactly the same thing as 1/5 A. If it makes you feel more comfortable, you can just put a 1 there in front of the variable. It doesn't matter. Anytime you see a variable and it's by itself, there's always a 1 in front of it. And like I said before, that's the same thing. 1/5 A is exactly the same thing as A over 5, because it would be 1 times A, or A. So I know that it's a fraction. A fraction is a division problem. The opposite of division is multiplication. We show the work by multiplying by the reciprocal of 1/5. The reciprocal is 5. All that's left on the left is A, and on the right, we have 150. If we were checking this, then we're saying 150 divided by 5 is equal to 30. And of course, that does check. And hopefully you're kind of catching on right now, because you're saying, okay, Miss McDaniel, I see this. If there's a fraction, then really all I'm doing is multiplying by the denominator. And that is true. You're multiplying by the denominator, but I teach you to multiply by the reciprocal, because if not, then when you get to a problem like number 3, you're not going to know what to do. I'm going to go ahead and just write this on the side, and so you can just write it somewhere on your notes, because I'm kind of running out of space and I want to leave up what I already have. So I've got 2/3 x is equal to 18. All right, so first of all, we know that 2/3 is the coefficient, and the rule is to always divide by the coefficient. So we are ultimately dividing by 2/3, but we saw that before. 2/3 divided by 2/3 is just looking weird. So instead of dividing by the coefficient of 2/3, we multiply by the reciprocal. The reciprocal of 2 over 3, guess what, is 3 over 2. At this point, you're going to be wanting to probably use your calculator, but I still want to show you the pencil and paper math of this, because ultimately you're just dividing 18 by 3 and then dividing it by 2. In your calculator, you can say 18 times 3 ABC 2, enter, and it'll give you the answer. But I want you to understand that really sometimes it's easier just to do it pencil and paper, because this is exactly what it looks like. So right now you're probably saying, okay, well, what did you do? Well, I know that I'm multiplying 18 times 3, but I'm multiplying by 18, but then I'm turning around and dividing by 2. So I can ask myself, well, what number goes into 18 and 2? 2 divided by 2 is 1. 18 divided by 2 is 9, and then 9 times 3 is 27. If you put that in your calculator, then you have exactly the same thing. As far as checking purposes, 2, ABC, 3. I'm sorry, 2 ABC, and then 3 times 27, and then you should, of course, get 18. So there's your check on that problem. That should do it for us for solving one-step equations. If this is 2013, then your notes are going to look a little different than your than the lecture. Just write down exactly what was on the lecture. Those problems are one step. What you had on your original notes were 2 steps on just the last few problems.